Yes. So, mainly we are going to discuss three topics here. One is coefficient of coefficient of coefficient of variation. It's not writing properly. Coefficient of variation. Then we will discuss moments, skewness, and kurtosis. Now, third one is correlation. So these three topics we will cover today. Okay. So first we will discuss about coefficient of variation. That is, if you have two sets of data, then we can check that which set data is or which set data has greater variability or less consistency. Okay. So we'll do one problem based on that. So before that, what is the formula for finding coefficient of variation? Coefficient of variation, you can find it by using the formula standard deviation divided by arithmetic mean into 100 into 100. What is the formula? Standard deviation divided by arithmetic mean into 100. This is the formula for finding coefficient of variation. So here you can find the arithmetic mean, standard deviation, etc. by using the different methods. Okay. One is by using the direct method. That is, if you have the data provided directly, then for example, arithmetic mean, you can find it by using the formula summation of all the values divided by the total number. Suppose that x1, x2, etc., xn numbers, the xn data are given over there. Then you can just simply add x1 plus x2 plus etc. plus xn, and here total number of data is n, so divided by n. So simply summation x divided by n is the definition of the general definition of arithmetic mean. If any frequency data is given, then the corresponding formula will be summation f multiplied by x divided by total number. This summation, this n means that simply summation f, that is the total frequency. Now, next is that if suppose the numbers are, these given numbers are a bigger number, then you can use the assumed mean method. Or if you have some, when you are finding the actual mean, if suppose that you are getting some decimal values as your actual mean, so it will be quite difficult for the further calculation. So in these cases, we can use or we can opt the assumed mean method. So in that case, out of this data, we will consider the, if it is in the ascending order, then which one is coming on the middle. That we can consider. If it is equally distributed, then we can consider the middle data. Or if it is not equally distributed, then you can find the total summation, and which is very nearer to that arithmetic mean value, that you can consider as the assumed mean. Okay, suppose that when you are calculating the actual mean, suppose that you are getting 49.3. Okay, suppose that if you are getting this is your actual mean, you can take either 49 as assumed mean or 50 as an assumed mean. It will be easy if you are considering 50 as an assumed mean for the further calculation. Okay, so in that way, you can use assumed mean method. Next thing is that if in question paper, if it is specified and given to you by using the assumed mean method, then obviously you have to use that method. Okay. So these are the different formulas you can use for finding actual mean. Actual mean you can use summation x by n, summation fx by n, that is if you have a frequencied one. If you have an assumed mean method is there, then actual mean, your x bar you can find by using the formula that assumed mean plus summation fd by n if you have a frequencies there, or if the frequencies are not given, then simply summation d by n. What is this d? D is nothing but the total summation, that is deviation from the corresponding values. So if you have, you can take a as an assumed mean, then the deviation from x is the given values. So each of these deviation of each of these values, we can call it as d. So this d is given over here. Okay. So this is the formula for finding the arithmetic mean if you are using assumed mean method. Okay. Similarly, we have the formula for finding the standard deviation is there. Till now, everything is clear?
Yes, ma'am.
Yes, so we have discussed about assumed mean. Okay. Now, next is the standard deviation formula. So, standard deviation formula, you can use sigma is equal to yes, root of 1 by n into summation f into x minus x bar whole square. 1 by n into summation of f into x minus x bar whole square. This is the actual mean method if they have provided. If you have, suppose that your assumed mean is given over there, or you can also write this formula as root of 1 by n into summation if you are using, this is your actual mean method, actual mean method. If you are using actual mean method, summation fx square minus summation fx by n whole square. Okay, so if you want, you can use this formula also. Or if you are using assumed mean method, then the formula will become sigma is equal to root of 1 by n fd square minus summation fd by n whole square, where d is nothing but deviation from the data. Deviation from the data. Okay. So we have required these formulas for calculating the coefficient of variation. So I hope that all of you have understood the formula and you have just revised these formulas, right? Yes, shall we continue?
Yes, ma'am.
Yes, so we will do one problem now based on coefficient of variation. Yes. So all of you write the question. Find which of the two group, which of the, sorry, not two group, which of the group shows greater variability. Find, 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 find out which of the group or which group shows greater variability. Greater variability. The data are group A, and group B. Group A values are 518, 519, 518, 519, 527. Very much lagging, I think. 528, 529, 530, 530, 531, 542, 544, 44, 550, 550. Group B, 814, 819, 825, 814, 819, 824, 825, sorry, 825, 826, 826, 830, 832, 832, 832, 835, 840, 842, and 844. Yes. So these are the datas given over there for finding the greater variability. So for each data, we have to separately find the coefficient of variation. Now here we can see that the values are on the bigger side. If you are taking as it is, then your columns will have a greater values when you're finding this squaring and all. So for reducing that value part, we will opt here the assumed mean method. Okay. So we will consider here in the question itself, if I am giving assumed mean, consider it as uh, from 530, that is coming in between. So let assumed mean is equal to 530 because the numbers are some bigger one, so we can consider or we can solve the problem by using the assumed mean method. So consider the assumed mean is equal to 530. Now we can write here for finding the coefficient of variation. What is the formula? I think my system is already hacked. Let me sign out and I'll join quickly because writing is also so much lagging is there. So for 5 minutes, maybe you'll be out of the meeting. Let me restart the system.
Show them who's boss, all right? Don't let me down. Wow, you blew his brains out. Nice. Got him.
Am I audible?
Yes, ma'am.
Okay. Is my screen visible?
Yes, ma'am.
Okay. Not working here. Is my screen visible? Yes.
Yes, ma'am.
Okay. Okay. So I'll write that question again. All of you have written the question. Find out which group has greater variability.
Yes, ma'am.
Yes. So now I'll directly form the table. Okay, so this is the question. Find out which group has greater variability. So the question, that means you have to find the coefficient of variation. Okay, so we have to find coefficient of variation of group A and coefficient of variation of group B. Okay, so we have to find coefficient of variation of group A. So let it be denoted it as CV of A. And next one, we have to find it as coefficient of variation of group B. So the formula is nothing but sigma by x bar into 100. Okay, standard deviation divided by arithmetic mean into 100. So for just for understanding that this is specifically for group A, I can just denote it as some sigma A and XA. Okay, just for understanding the difference for group A and group B. Okay, and coefficient of variation of group B is denoted. The formula is same, but for making for understanding that this is for group B, just write it as sigma of B and arithmetic mean of group B. Okay. Till now everything is clear? Yes or no?
Yes, ma'am.
Yes. Now first we will consider for group A. So
Hello,
what
ma'am.
are the, yes?
In previous slide, you took the assume in A bar 530.
Yeah.
I have not understand how.
What was the group values I have provided? 518, 519, 527, 528, 529, 530, 531, 530, 542, 544, and 550. Yes, these are the values provided for group A, right? Is or
Yes,
no?
ma'am.
Yes. So there are two methods for finding assumed mean. Either means if you have not provided any number as an assumed mean, then what you have to do is you have to add the summation of all these values. And what are the total number here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 datas are given over here. So add all these values, divide by 10. So if you are getting a number, means an integer, then you can consider that as an means actual mean method, and you can continue the same if you are getting an actual integer. If you are getting a decimal value, suppose that after summation you may get some, suppose that 523, something like that, point 3 or 4. Suppose that when you're calculating the actual mean, you're getting this type of decimal number, then either you can consider 524 as assumed mean or just nearer value in this. Okay. So if you want, you can consider 527 as assumed mean. Anything you can consider. If we have not provided, if you have not provided any number. Okay. So in this problem, I have given that take as assumed mean as 530 that I am giving here as an question. Consider 530 as an assumed mean. Okay. If suppose that these data are equally distributed, so means that 20, 25, 30, 35, 40, 45 like this. Okay, so here the distribution is uniform. The difference between each number is same. So the distribution is uniform. Then if you want, you can take the middle number. Here it is an even number, then either you can choose 30 or 35. If you are getting an odd number, then the middle one, you can consider it as an assumed mean. Is that part clear? How can you find the assumed mean?
Yes, ma'am.
Yes, so first you can calculate actual mean. If it is a decimal, then just take the very nearest integer. Or other case, if it is equally distributed, just take the middle one. Or if third part is that if they have or we have given directly that you have to consider this as an assumed mean. Okay, in that case you have to choose that. So here in this problem, I just give that consider 530 as an assumed mean. That's all. Clear?
Yes, ma'am.
Okay, so now I'm going to calculate sigma and x bar for group A. For that, first I'll write or denote for group A as x and for group B as y. Okay, so the datas of x are 518, 519, 527, 528, 529, 530, then 531. Then 542. All of you are writing, no?
Yes.
Yes, if you are solving, then
Yes, ma'am.
only the use of this remedial is there. Otherwise, there is no use. So these are the values they have provided. Now I have just given that let 530 consider it as an assumed mean. Okay, because the values are bigger. So if you are taking the actual mean method, the bigger values are coming. So for reducing the calculation, I am using this assumed mean method. So D is equal to x minus A. That means A is nothing but your 530 assumed mean. Okay, D is equal to x minus 530. So what will come over here? 518 minus 530. Now you complete this column and just tell me one by one. What is the value you are getting over here? 518 minus 530. What will come? 518 minus 530.
Minus
12.
Minus 12.
Yes. Now 519 minus 530.
Minus
11.
11.
Yes. 527 minus 530.
Minus 3.
Yes.
Minus
528. Yes. Complete. Minus 3.
minus
Then
2.
minus
Minus
2.
2. Minus
Yes.
1. 0.
Yes.
1.
Yes.
12. 14.
Yes. 12. 14. Then
And
20.
20.
whether I have missed one here. I have missed one here. This is 1, then 12, then 14, then
20.
20.
20.
Yes. What
20.
is the summation?
$18.
Yes, 80.
18.
Yes. Now, what is the formula for finding this sigma and x bar? If you are using assumed mean, what is the formula? Root of 1 by n into summation d square minus summation d by n whole square. Yes or no?
Yes.
Here frequency is not there. That's why here d only. Otherwise frequency is there. Then I have to multiply it by f. Okay. So frequency is not there. So I have required what d I have. So this summation d I have got here now. Next I have needed summation of d square. Means that next column I have required is for d square. Okay. So all of you quickly find d square. Yes. Yes. Quickly complete the column. 12 square.
144.
144.
121.
Yes.
9.
Yes.
4.
Yes.
1 0. 1.
Yes.
144.
Yes. Yes. 14 square.
196.
196 and then
200.
400. Correct.
400.
Now quickly find the summation.
1020.
1020. So I'll calculate the corresponding for this group A. So I'll first write the formula. This is the summation. So the formula for finding sigma is equal to sigma of A is equal to root of 1 by n summation d square minus summation d by n whole square, which is equal to, what is the total number we have considered here? What is your n here? What is your n here?
10.
10.
10.
10.
Yes. Now, summation d square is equal to 1020 minus summation d is equal to 18 divided by n is your 10 whole square. Quickly find this value.
2.63.
2 points.
Yeah, 2.63.
Oh. 1020 by 10. 102 minus 1.8 whole square.
9.93.
Yes, 9 point,
9.93.
yes, 9.93. Clear where you have made mistake? Yes?
Yeah, ma'am. Got it.
Yeah, okay. So this is for summation, standard deviation formula and actual mean for group A because we have used the assumed mean, right? So actual mean is equal to assumed mean plus summation D by N. Okay. Assumed mean we have taken is 530. Summation D is 18. N is 10. What is this value?
Nine 54.
5?
531.8.
Correct. 531.8. All of you have got 531.8?
Yes, ma'am.
Yes. Now we can find the coefficient of variation of this group A. So coefficient of variation of group A is equal to what is the formula? Standard deviation divided by arithmetic mean into 100. Standard deviation is 9.93. Arithmetic mean is 531.8 into 100. So can anyone tell that what is this value?
1.8.
0.01.
1?
1.8.
1.8. Yes?
Yes.
Okay. So we have found the coefficient of variation of group A. Similarly, we have to calculate for group B everything. So let be that group B we can consider it as some Y and write all the values quickly. 814, 819, 825, 826, 830, then 832, 32, 835.
Ma'am, do we have medium and mode this time?
No, we are not
Okay.
going to ask anything.
And continuous data?
Uh, Continuous data may come. For that, we will do the problems based on that in moments we will do. Okay, so that will be practice for finding standard deviation and arithmetic mean. Okay,
And scrutiny?
which one?
Scrutiny?
Which one? Skewness.
Kurtosis and
That also is there. I have already mentioned that today we are going to discuss about this coefficient of variation, moment, skewness, kurtosis, and correlation. These three topics.
okay, ma'am.
Clear? Yes. Yes, 835, 840, 842, and 844. Now, what are all things that we have done just now? The same procedure you have to continue for finding here. If you want, you can consider this as your DA, group A. And this is for group B. What is that? X minus B. If you want, you can consider that is your arithmetic mean. You can consider as some B. Okay. So take assumed mean for this group B as some What is the lowest and minimum value and higher value? Let it be some 30. Yes. Take 830 as assumed mean. As assumed mean. So between this 814 and 844, I have just taken roughly 830 as an assumed mean. Okay. Or if you want, you can add all these values and find the total value divided by the number 10. Then obviously you will get a decimal number. So just nearer to that number, you can also consider. Okay. So if you have not provided any value, you can do like that also. No issue. So take 830. 830. Yes, quickly calculate this column.
Minus
7.
16.
Yes, yes. Just a minute. Minus 16, yes.
Minus
Minus
11.
11.
Yes.
Minus
Minus
4.
5.
Minus
5.
5.
Minus 4.
Yes, minus 4.
0.
0,
2.
2, 5,
10.
10,
12.
12,
14.
14. Quickly find the sum.
7. 7. 3.
7, 7. What is the answer? Yes. Yes.
7.
What is the answer? Yes, 7. So this column we have completed. Now next I have required, let it be some DA for showing the difference for group A and group B. Yes. Or even if you can also denote it as U or V. Okay, that is also possible. Instead of D, you can say U, and DB, you can say V. Okay, so in that case, then there is no need to write any suffix. Yes, now quickly take the square.
256.
Correct,
121.
correct,
25.
correct,
16.
correct,
0. 4.
correct. Yes,
25.
yes,
100.
yes,
144.
correct.
196.
And total summation
887.
887. All of you have got the same? Just check that. I have
Yes.
not checked the summation. Okay. So just like the previous case, we can calculate the standard deviation for group B by using the formula 1 by n into summation d square minus summation d by n whole square. And here the values are, here also n is equal to 10, right? Yes or no?
Yes.
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 Yes, yes. Recording is there, na? Continuing, na?
Yes.
Okay. Summation d square. Where is summation d square? Yes. 887, right?
Yes.
Yes. Minus summation d is your 7, n is your 10, then 7 by 10 also. Quickly find what you're getting.
9.39.
9.39. Now I have to find the arithmetic mean. That is for group B. That is assumed mean. Assumed mean here we have taken it as B plus, what is your summation D? Summation D is N. What is your assumed mean? We have considered 830.
830.
30. Yes. 830. So 830 plus summation D is 7, N is 10. So what you are getting here total? Yes,
80.7.
830.7.
830.7. So here I can find coefficient of variation of group B by using the formula standard deviation divided by arithmetic mean into 100. Standard deviation is 9.39 and actual mean is 830 into 100. What is coefficient of variation?
1.13.
1.13. Yes. Now you just tell that coefficient of variation, how can you identify that? Which group has greater variability or which group is less consistent?
Whose variance is more, its consistency is less, and whose
Yes,
variance is less, its consistency is more.
yes. So here we can say that the coefficient of variation of group A, you are getting it as 1.8 and coefficient of variation of group B is 1.13. So coefficient of variation of group B is less than group A. Yes or no?
Yes.
Yes or no?
Yes.
Yes. So I can write that coefficient of variation of group B is less than coefficient of variation of group A. Therefore, group B is more consistent. Here, what is the question here? Greater variability, na? What is the
Yes.
question? So if it is greater variability, then group A has greater variability. Yes or no?
Yes.
Yes. Greater variability is for group A. Less variable is group B. If the group is less variable, then that will be more consistent. So this was an additional data. Our question and answer of the question is this. Because this value is more. So it has greater variability. Variability. Clear? CV clear?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes. So this type of question you can expect for your end semester examination for finding the coefficient of variation part. So the question may be not like this that finding greater variability. You can expect that which one is more consistent or like that. So that type of question you can expect. So any doubt is there in this coefficient of variation?
No.
Okay. So all of you have completed this, right?
Yes, ma'am.
Yes. Yes. Now we will discuss about moments, skewness, and kurtosis. So first we will discuss about moments. The formulas we will discuss here. And afterwards, the formulas for skewness and kurtosis part we will discuss. Okay. Yes. Here again, moments about a value will be there. That is your assumed mean part. About any number is given over there. So obviously you have to use the assumed mean method. So if you are use that assumed mean or moments about any point, we can call it as row moments. Moments about mean, that is moments about the arithmetic mean, is known as the central moments. So sometimes the data, when you're getting the data just like this, it will maybe the bigger one. So it will be quite difficult to calculate the variance or the variations directly. So with the help of the row moments, we will find the central moments. That is moments about mean. Moments about mean is known as central moments. Moments about any number. About any number, any arbitrary number, that we can call it as row moments. We can call it as row moments. So central moments and row moments are there. In this, if you are considering the direct definition of central moment is, it's nothing but the arithmetic mean of the deviation from this actual mean. Okay. For example, mu1 is nothing but it's a deviation arithmetic mean, that is 1 by n of summation of, if frequency is there, then you have to multiply it by f, and the deviation from this data from this means arithmetic mean from the corresponding data. So this is nothing but your mu1. If mu2 is there, then the corresponding power is increasing. So generally, if you are considering this as mu r, then this power raised to r will be there. Okay, so this calculation is quite difficult if you are calculating it directly. That's why we are using these row moments. So with the help of these row moments, we will find these central moments. So what is the corresponding definition of row moments if this is the definition of central moment? So row moments is denoted it as mu r dash generally. So generally we can write it as again 1 by n summation f if frequency is there. Instead of that x bar we have a is there, nothing more. This is the definition for row moments. So here you have actual mean is there. Here you have the corresponding row value will be there, means the about any value is there. Okay. So if you have considering mu1 dash, then the corresponding definition is 1 by n into summation f into x minus a only. R is equal to 1. Now, if you are considering mu2 dash, then the corresponding is equal to 1 by n into summation f into x minus a whole square. Okay. So for mu3 dash, it will be raised to 3 f into summation f into x minus a all raised to 3, and mu4 dash will be 1 by n into summation f into x minus a all raised to 4. Okay, so for calculating these row moments, if you have considered this as some d, then what all things you have to find? Summation of fd. If suppose that this is your d, then summation of fd square, this will be a d square, this will be a d cube, this will be a d raised to 4. So in the column, this one I can directly write it as summation of fd. This is nothing but summation of fd square. This is nothing but summation of fd cube. This is nothing but summation of fd raised to 4. So till fourth row moments or fourth central moments, you will get all the data or characteristics of that particular distribution. So we will find till fourth row moments as well as the central moments. So for finding that particular columns, we will use this way: fd, fd square, fd cube, fd raised to 4. So we have already find the data for finding or the formula for finding the row moments. Then from these row moments, how can I find the corresponding central moments? Okay, so mu1 will be always 0, because if you are getting an equally distributed data, when you are finding the summation, you will get always mu1 will be 0. Now mu2 is equal to mu2 dash minus mu1 dash whole square. So this is the formula for finding the central moment, mu2 part. So this formula at any cost you have to remember. There is no other way. So mu3 is equal to mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash whole cube, mu1 dash whole cube. Then mu4 is equal to mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash square minus 3 mu1 dash all raised to 4. So this formula you have to remember, because once if you have found the central moment, you have to find the means row moments, you have to find the central moments. Okay, so mu1 will be always 0, so no need to find the mu1 value. So you can remember in this way for finding mu2 dash minus, if it is second is there, then mu1 dash whole square. Now next you have to find mu3. So obviously we'll start from mu3 dash. Now the combination of mu2 dash and mu1 dash, and it is 3 is there, so 3 times mu2 dash mu1 dash plus then 2 times mu1 dash, because 3 is there, so mu1 dash all raised to 3. 2, don't forget that. Okay. Now next is mu4. So starting with that mu4 dash, then 4 minus 4 into the combination of mu3 and mu1. Now combination of mu2 and mu1. Here it is square is there. Okay, so this part is increasing mu1. Now last you have mu1 dash raised to 4. Okay, so in this way, if you want, you can remember, or you just write some maybe 5 times or like that. You can remember this formula. Okay. So these are the formulas for finding row moments and central moments. Okay. So once if you have found the row moments and central moments, you can find the coefficient of skewness. Coefficient of skewness. We can denote it as beta 1. The formula is mu3 square. This is the central moment. Whatever you are getting over here after this. These values you have to write over here. Okay, mu3 square divided by mu2 cube. This is the formula for finding coefficient of skewness. Similarly, the coefficient of kurtosis. You can find it by using the formula beta 2 mu4 divided by mu2 square. Okay, so skewness means that how much deviation is there from that particular normal curve. So if you have a normal distribution is there, then you will have a curve will be like this normal. But if you have the corresponding skewness part is there, negatively skewed or positively skewed. Yes. Is any doubt? Any doubt is there? Is Ajinkya Sate? Ajinkya Sate, any doubt?
Coefficient point is not visible. If
Yes. So this is the normal distributed curve, and if it is skewed towards the right, suppose that this is towards the right is there, so this will be positively skewed, and it is towards the left, then that will be negative. So how much stretching is there towards the right or towards the left, then that will be corresponding to positively skewed or negatively skewed. So how can you get it identified from this formula that whether the distribution is negatively skewed or positively skewed? So that we can consider about this value of mu3, because here when you are finding this value, the value will be always positive, but it is not necessary that that particular distribution is always positively skewed. Okay, so you must have to check what is the value of this mu3, and if that value of mu3 is negative, then even though the value of beta 1 is positive, but that will be negatively skewed. Is that concept clear? You have to just check mu3 value, and mu3 value, if it is negative, mu3 value is negative, then this skewness will be negatively skewed even though you are getting a positive value. Is that part clear? Is that part clear?
Yes.
Yes.
Yes. So yeah, so you have to check always the value of mu3, whether this mu3 is negative or positive. If this mu3 value, the central moment, mu3 value is positive, then this beta 1 will be positive. Then obviously the skewness will be positively skewed. If mu3 is negative, even though value of beta 1 is positive, but it will be negatively skewed. And if mu3 is positive, then you'll have the distribution is positively skewed distribution. Is that part clear?
Yes.
Yeah, so you have to check the value of mu3. Now here you can find the value of beta 2. So here also we have to check one particular condition is there. The condition is here 3. That is, if beta 2 is equal to 3 means that it is the normal curve, this one, normal curve. If beta 2 is less than 3, then we can say that that is platykurtic. The distribution is platykurtic. And if beta 2 is greater than 3, then that distribution is leptokurtic. And if it is equal to 3, then that is your normal curve. And we can also call it as the mesokurtic. Mesokurtic. We can call it as mesokurtic. So here in moments, you have to remember the formula for finding the row moments. The row moments here, the row moments, these are the row moments. These are the row moments. So you have to remember this formula. Row moment, then the formula for central moments. Mu1 will be always 0. Then mu2, mu3, mu4. Then you have to remember the coefficient of skewness and coefficient of kurtosis. Just remember the limits also. Till now, everything is clear?
Yes.
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 Yes. All of you have written the notes. Shall we continue the problem?
Yes, ma'am.
Yep.
Yes. Yes. So write the problem. Question. Compute the first 4 central moments for the following frequencies. For the following frequencies. Number of jobs completed. Number of workers. Zero to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. So these are the data given over here. So you have to find the first 4 central moments for the following frequencies. So we will do skewness and kurtosis also here, extra additionally. Okay, also find coefficient of skewness and kurtosis. Comment on it. Comment on it. Okay, that means whether the distribution is platykurtic or like that, or negatively skewed or positively skewed. So that is the comment part. So we'll do that also. All of you have written the question? Yes.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So now we will form the table and we will do, because this is the class interval is given over there. So this is the continuous distribution part is there. So we'll form the class. We are not going to write all those things here. Simply write class interval. Put all there 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Yes. And then we will find here the midpoint. Midpoint. What is the midpoint here? 5, 15, 25, 35, 45. Midpoint, if you want it, you can denote it as X. Then next is your frequency. Frequency is nothing but this number of workers, which is belonging into that particular integral. 6, 26, 47, 15, and 6. What is the total number? Yes,
100.
100. Okay. So here, what is the question here? We have to find the first 4 central moments. Okay. So if you are going to find first 4 central moments, first we will find the row moments. So for finding the row moments, what is the formula here? What is the formula here for finding row moments? Summation of FD. What is this D? D is nothing but X minus A. So obviously we have to consider the assumed mean path about any value. So this A is nothing but the assumed mean. Okay. So what all columns I have required? FD, FD square, FD FD raised to 4. Okay. So first we have to identify what is your assumed mean. Since this distribution is continuous, that means the gap between these is same. So we can consider the middle one, that is 25 as the assumed mean. So these are your values X, and you're taking the deviation deviation from each of these data, that is X minus 25. Okay. So I'll complete this part also. Next, I have to multiply it by F, then I'll get FD. Then I have required FD square. The increasing is only for D, not F.
Ma'am,
Now, yes,
means are we
yes,
supposed to divide the x minus 25 by 10, or if we just keep it
yes,
the same, then is it okay?
yes, yes. One more thing is there. If you're dividing it by this class interval, then there will be a change in this formula. So if you are dividing by that particular class interval, then there is a change in this formula. Suppose that if you are dividing this x by a by that class interval, if you are denoted it by I, then I have to multiply it at the end here. When you are finding this value, you have to multiply it by I. Okay, for when you are calculating this mu1 dash. Okay, otherwise your answer will be wrong if you have not multiplied. So if you have taken this D is equal to X minus A divided by your class interval, when you are finding this mu1, you have to multiply it by I. This is your D. If your D is taken it as divided by I, then for mu1 dash you have to multiply it by I, then this I and this I will be cancelled. Is that part clear? If you have not multiplied by this I, then your value will be invalid. Similarly, if you have I square is there in mu2, then you have to multiply it by I square. Okay. So if you have whatever the division part is there, Accordingly, you have to multiply it by here. Otherwise, your value will be invalid. Is that part clear?
Ma'am, means are we supposed to put the I value over there or not? Because in D we are already dividing it by I, na?
If already
So
dividing, yeah, if you are dividing it by I, here you are dividing na, in this part. If you are
yeah, exactly.
dividing, yeah, if you are dividing it by I, for equalizing that, you have to multiply it by I. So you are getting a value here, right? After dividing by I, you are calculating summation by multiplying by F with that each values. Then obviously you'll have a value here after summation. So whatever you are getting, you have to multiply it by I. Then only you will get your actual mu1 dash, because you are reducing the values, right? Is that part clear? You are not only taking the
Yes,
deviation, your
and
deviation divided by that some value is there. So it will be very small value. That will be easy for the calculation, but you have to get the actual value too, right? Is or
so
no?
ma'am, is it means if we don't divide that D by I, then it's not necessary to multiply the whole equation by I,
No,
or
no need to
we
multiply.
have
You can
to.
continue.
Okay,
Yeah, you can continue
okay,
with this formula if you are not dividing. If you are dividing accordingly, you have to. If mu1 dash is there, multiplied by I. Mu2 dash is there, multiplied by I square. Mu3 dash is there, multiplied by I cube. Mu4 dash is there, multiplied by I raised to 4. Because here the power is increasing. That's why. Clear? So if you are dividing, then you have to multiply it by
yes,
I
ma'am,
for
clear.
equalizing this part. If divide by I, then divide by I. If it is divided by I square, means this square is there, then multiplied by I square. Cube is there, then you have to multiply and cube. Okay. We can do that part here so that the calculation will be very easy. But don't forget at the end part, multiplied by I. Since the class interval is 10 everywhere. Okay. So you can denoted it by or divided it by 10. So don't forget to multiply it by 10 at the end. That's all. Nothing more. Yes. So quickly find the D value. This is your X. This is your X value. And from this you have to take the deviation 25. So 5 minus 25 divided by 10. So 5 minus 25 is simply taking, then you are getting minus 20, right? So if it is minus 20, then minus 10, 0, 10, 20, then you'll have a equalized value will be there. If you're dividing by 10, then you are getting a very, very small value. So for equalizing, you have to correspondingly multiply it by the power of 10. Okay. So 5 minus 25 is minus 20 by 10 is minus 2. Yes or no? Then minus 1, 0, 1, 2. All of you have got the same?
Yes, ma'am.
Yes. So instead of 20, we are getting 2 only because of this divided by 10. Okay. Yes. Now quickly find FD, product of this F and product of this D. What you are getting? Yes. Quickly. Yes. Yes or no? FD square. FD square means that F into D square. Is that clear? Not this square. Students are making the mistake that whatever you are getting over FD, they will take the square of this 12 over in this second. It is not like that. You have to multiply it by this F and square of this D. That is 6 into 4. Is that clear?
Yes, ma'am.
Yes.
Yes, ma'am.
So just complete this column quickly. 24, then 26 into 1 square. That is 1 only. So
26,
26. Yes. Next is 0 only.
0, 15,
Yes.
21.
Yes, 15 into 6 into 4. 6 into 4. 6 into 2 square. That is 24. What is the total summation? What is total summation of FD also? I have
89
forgot to. 89. And what about this summation?
minus 1.
minus
1.
1 आ रहा है नहीं 1 नहीं आता ये
minus
20
11.
yes minus 11 correct ये तो 27 है and this is 38 so 11 आ रहा है yes similarly f d cube multiplied by this f and cube of this d okay that is 6 into 2 cube minus 2 cube that is minus 1 minus 1 will be there so quickly find 6 into minus 2 cube. Yes.
Minus 48, minus 26,
Yes.
0,
Yes.
15, 14,
Yes.
48, 48.
Correct. Yes. What is the total summation?
minus 11.
Minus 11. Now, similarly, f d raised to 4. F into then fourth power of this d. That is 6 into minus 2 raised to 4. Yes, complete the table.
Ma'am, 96, 26, 0, 15, 96.
Correct. And total?
And summation is 233.
Correct. 233. Now we will find the row moments. Row moments formula is mu1 dash is equal to summation 1 by n into, what is the formula I have written over here? 1 by n into summation x minus a divided by I into f. And for equalizing this I have to multiply it by this I. Okay, so 1 by n into summation fd. So I into, so don't forget to write this I into summation fd by n. Next is mu2 dash. I square into summation fd square by n. Next is mu3 dash is equal to I cube into summation fd cube by n. And mu4 dash is equal to I raised to 4 into summation fd raised to 4 by n. Yes, quickly find all these values. So I means 10, summation fd. I think this is summation fd minus 11, right?
Ma'am, minus
FD.
1.1. Mu1 is minus 1.1.
Yes, just a minute. Let me complete this. Yes, divide by what is that n here? This is your n. Summation f. N is equal to summation f. Total frequency. That number is your total number n. Yes. So what you are getting? 1 point?
Minus 1.1.
Next.
8.1.
Just a minute. I'll complete mu2 dash. So 10 square into, what is your summation of d square? That is your 89 divided by 100. What is this value?
81. 89, sorry.
89. Because 10 square and 100 will be cancelled. Next is 10 cube into fd cube is minus 11 divided by 100. What you are getting?
Minus 110.
Yes. Because 1 0 will be remaining over there. Next is 10 raised to 4 into fd raised to 4 is 233 divided by n. That is your frequency. What you are getting?
23,300.
Yes. All of you have got the row moments?
Yes.
Yes, ma'am.
Yes. Now we have to find the central moment. So quickly write the formula first. Central moments formula. Mu1 dash is always 0. Sorry, mu1 is always 0. So the central moments are, these are the row moments. So write central moments are mu1 is always 0. Mu1 is always 0. Now mu2, you can write the formula first. Mu2 dash minus mu1 dash square. What is your mu2 dash? 89. What is your mu1 dash? Minus 1.1. So minus 1.1 whole square. What is this value? Yes, what is this value?
87.79.
87.79. Okay. Now mu3 is equal to mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash all raised to 3. Means that minus 110, that is your mu3 dash, minus 3 into mu2 dash was 89, right? 89 and mu1 dash was minus 1.1 plus 2 into mu1 dash was minus 1.1 whole cube. Quickly calculate this value.
One 181.038.
181.03.
Yes.
Okay, now mu4. Quickly write the formula first. Mu4 dash minus, yes,
0.38.
0.38.
Yes. 8 is remaining.
Acha, 8 is remaining. Okay, no issue. Yes, for what is that? Mu4 is equal to mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash square minus 3 mu1 dash raised to 4. This is the formula. So I have to substitute all the values here. That is mu4 dash is 23300 minus 4 into what was your mu3 dash minus 110. What was your mu1 dash minus 1.1? What is your mu2 dash is 89. mu1 dash is minus 1.1 whole square. Then 3 into minus 1.1 all raised to 4. Yes. Quickly find this value. What is the value? Anyone who have calculated?
234
2, 3, 4,
57
5, 7,
47
point 7,
47.
4. 747.
Yes.
Okay. So all of you have got these values?
Yes, ma'am.
Central moments? Yes. So I have added 2 more questions over there. You have to find the coefficient of skewness as well as the kurtosis part, and you have to comment on it. Okay. So coefficient of skewness you can calculate by using the formula beta 1 That is mu3 square divided by mu2 cube. What is your mu3 here we have got? 181.038. So this square divided by mu2. Mu2 is this. 87.79. What is this value? All cube. What is this value? Quickly find.
0.04.
0.04. Okay, so I have already mentioned that beta 1, when you are calculating this formula, you will get always a positive value here. But you have to check that what is the value of mu3. So here you can see that the mu3 value is positive. So we can say here, since mu3 is positive, since mu3 is positive, it is positively skewed. The distribution is positively skewed. The distribution is positively skewed. This is the comment. The distribution is positively skewed. Now, coefficient of kurtosis, that you can find it by using the value beta 2. The formula is mu4 divided by mu2 square. mu4 value you can see here 2, 3, 4, 5, 7.747. 747 whole divided by mu2 square. What was the mu2 value? 87. 87.79. So this one whole square. So quickly find this value too.
3.04.
3.04.
3.043.
Okay, so means that it is greater than 3, right? So
Yes.
B2, yes. So B2 is greater than 3. We can say that the distribution is
Leptocrit.
distribution is yes, leptocurtic. Leptocurtic. The distribution is leptocurtic because it is greater than 3. Okay, so this is the comment that we expect. So this problem is clear? Any doubt?
Yes, ma'am.
Moments, raw moments, central moments, coefficient of skewness, and coefficient of kurtosis. Clear?
Yes, ma'am.
Okay.
Yes,
So
ma'am.
you can expect such type of problem in the examination. Now one more topic is remaining, that is correlation. Quickly I'll take one problem based on that too. Correlation. So obviously here also you will have given the two separate datas, and you have to find what is the relation between those two variables. Okay, so you'll have given some x variable and y variable datas, and you have to check that what is the relation between these two variables. So this thing you can find it by using this correlation analysis. And here we can, there are many formulas for finding this correlation coefficient. Out of this, we are discussing only one, that is Carl Pearson's coefficient of correlation. Carl Pearson's coefficient of correlation. And the formula that what we are going to use is R is equal to, this R is nothing but the coefficient of correlation. So R is, you can find by using the formula covariance of xy divided by sigma x into sigma y. So sigma x into sigma y means that it is a standard deviation based on the x variable and based on the y variable. Okay. So here also we can find by using the actual mean method and assumed mean method. So if you are using the actual mean method, then the formula will be, that is, you have to just find the covariance value. Okay. So if you are using actual mean method, so you can just compare and study these formulas. This is a general formula for finding R. So you can remember this formula, and remaining thing you can easily write from that. So covariance of xy, you can write, if it is an actual mean method, the formula is, so 1 by n into summation of xi yi minus x bar y bar. So this is the formula for finding the covariance, divided by, now you know the formula for finding sigma x and sigma y. Okay, that is nothing but root of 1 by n summation xi square minus summation xi by n whole square. We have already discussed that. So root of these thing you have to write 1 by n into summation y square yi square minus summation yi by n whole square, because for each values. So you have to remember this formula. Based on that, you have to extract this. Okay. So this is the formula for finding the covariance, divided by, this is your sigma x and this is your sigma y, that you know already. So this is the actual mean method formula, and assumed mean. Again, it is the same type, only the variables are changed. So here I am using, instead of dA and dB, suppose that A and B are the assumed means of x and y respectively. So what you are using, usually dA is equal to x minus A and dB is equal to y minus B. Okay, instead of that dA and dB, I'll take it as U and V. So there won't be any confusion based on this. Okay, so instead of this covariance of xy, it will be covariance of E by sigma u into sigma v will be there if you are using the assumed mean. So what changes will occur on the formula? It's nothing but 1 by n into summation ui vi minus u bar v bar. Nothing to remember separately. The same thing is there, but that u and v are, it is the deviation from the assumed mean. Okay. And sigma u will be what? 1 by n into summation ui square minus summation ui by n whole square, and here it will be 1 by n into summation vi square minus summation vi by n whole square. So you have to just remember only the covariance formula, and that will be repeating again for the assumed mean. So nothing is different over here, because I have just taken directly this u and v form. So this formula is clear for finding correlation for actual mean method and assumed mean method. You have to remember this formula, covariance of xy by sigma x into sigma y. Clear?
Ma'am, in actual mean method,
Yes.
the n should be divided just by summation of xy or the whole summation of xy minus xy.
No, only this part. This part is multiplied by n. This part is free from n.
Okay.
Clear? Clear?
Yes.
Okay. So you have to just remember this R is equal to covariance by sigma x into sigma y for actual, and for assumed it will be covariance of uv by sigma u into sigma v. So you can easily remember this formula. So we'll do one problem based on the same. So I'll do the problem based on assumed mean. The same problem, if you want, you can do it by actual mean also. Or I'll give you another problem, because actual mean, if you have some decimal point is there, then I'll give another one for practice. Yes, so we'll do the problem based on the second one, assumed mean. Quickly write the question. Calculate, I am not giving the whole question as it is, just find, calculate Carl Pearson's coefficient of correlation. Calculate Carl Pearson's coefficient of correlation between X and Y data. Actually, these X and Y data are marks in some two subjects are there. Okay, so let it be whatever be the question. So let that write that X and Y data. Otherwise, it will take another 5 minutes for writing the question. So whatever be the XY data, write it directly here, and we will find what is the relation between these two. 23, 25, 28, 22, 42, 38, 17, 21, 26, 27, 35, 39, 29, 24, 37, 32, 16, 18, 46, 44. So this is the data, and we are going to find, is there any relation between these two? That is, how much related these X and Y are, how much interrelated. Okay, so one thing that you have to remember is that this Carl Pearson's coefficient of correlation, that is the range of this R, always lies between -1 to +1. So when you're calculating and if you're getting some other value, which means that your answer is wrong or your calculation is wrong. So always the value of R will lies between -1 and +1. And if the value R is equal to 1 means that it is perfectly positively correlated. And if R is equal to -1, it means that perfectly negatively correlated. And if R is equal to 0 means that there is no relation between these two. Okay, so if some value R is nearer to that +1 value, means that it is highly positively correlated, means that it is tending to that highly positive correlated part. If it is towards the negative side, that is tending to the negatively correlated. Okay, so you can write accordingly the comment. So you can check that whether your answer is right or not by checking what value you are getting your R. So it should be lies between -1 and +1. So if you are using the assumed mean, let the value or what is that in between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and what is the smallest value here? 16. And highest value you can see here is 46. So it's near about some 35. So let assumed mean for X is 35, and let assumed mean for what is the smallest number in B criteria is 18, and highest number you can see is 44. That is 62. That is some. That is 18 and 44. Which one is? Can take some 39. Let it be. Let 35 and 39 be the assumed means of X and Y. So I'm providing. You have to take these two as the assumed mean. Okay. So what will be the corresponding columns? If you have provided the assumed mean, then you can calculate as it is. Okay. If you have not provided anything, you can calculate by actual mean method, assumed mean method, any method, which one is feasible for you. Okay. Yes, so we will find X column, Y column, Now, what are columns we have required? I'm using here assumed mean. So, assumed mean I am taking u. Na? That difference is I am taking it as u. What is the difference? X minus 35 and v will be your y minus 39. Yes or no? Yes or no? Instead of d, I am
Yes.
taking u and v. So that dA and dB, that suffix you can avoid. That's why. If after finding u and v, what all columns I have required for finding? Summation of u and v I have, product of uv I have required. Then u square I have required. V square I have required. So I have required 3 more columns. uv or u square, v square and uv. These 3 columns are required. Yes or no?
Yes.
Yes. Now quickly complete this table. 23, 28, 42, 17, 26, 35, 29, 37. Have missed any values? Is that 23, 28, 42, 17, 26, 35, 35, 29, 37, 16, and 46. Y values are 25, 22, 38, 21, 27, 39, 24, 32, 18, and 44. So quickly find the next column U. X minus 35. Yes. 23 minus 35. Yes, quickly.
Minus 12, minus 7.
23 minus 35. Minus 12, then 28 minus 35.
Minus 7,
Minus 7, yes.
7,
7, yes.
minus 18,
Yes.
minus 9,
Yes.
0,
Yes.
6,
Yes.
minus 2,
Yes.
19,
Yes.
minus 9.
Minus 9. Now, B. Y minus 39. Those who find another column, you can quickly tell that. Don't wait for completing here.
Excuse me, ma'am.
Yes.
Ma'am,
Only two.
second last one and fourth last one is has a minus in them, I guess. In U.
Yes, yes.
99.
Here it is minus and second last. Yes, it is minus. Correct. Yes, B is completed. If someone completed B, then quickly tell me that.
It's minus 14,
Yes.
minus 17,
Yes.
minus 1, minus 18,
Minus.
1,
Yes. Which one? 1. Yes. Then.
minus 18,
Yes.
minus 12,
Yes.
0,
Yes.
minus 15,
Yes.
minus 7. Ma'am,
Yes.
that is minus 15.
Yeah, minus 15. Correct. Correct.
Then minus
Ah,
21
yes. Next.
and 5.
Yes. Now you have to take the product and square and then their summation. Yes, next I have needed U square. U square, this square of this column, quickly. Yes. Yes.
Ma'am, 144.
49,
49.
Yes. Yes.
49.
Yes.
324.
324,
Yes.
81,
Yes.
0, 36,
Yes. Yes.
4, 361,
Yes.
and 25.
Yes. Yes. And 81, na?
Yes, ma'am. 25.
Yes. No, 9. Here 9 hai. 19, then 9. Here 9, na? 46 minus, yes, 9 hai.
Yes.
Clear? It's 81. Yes or no?
Yes, ma'am.
Yes. Now V square of this. Yes. Next. Yes. Quickly.
Ma'am, 196.
Yes.
289. 1.
Yes.
324.
320,
Yes.
144.
144,
Yes.
0,
Yes.
49, 441,
Yes.
95.
Yes. Yes. And UV. U into V. U into V. Product of U and V. Yes. 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 Quickly.
Ma'am,
Yes.
I think so there is a correction in U last value. X
Which
is
one?
40 in U last value.
In U last value. हाँ बताओ.
46 minus 35, it is 11 na? Positive 11.
46. हाँ ये correct है. It's not 9.
And ma'am, third one also, ma'am, plus
It
2
is
है.
plus.
Last
It
third
is
plus
plus.
2.
ये correct है ना अभी 11. तो इधर
Yes,
आएगा
ma'am.
121. इधर आएगा 121 then. U square. And फिर इधर आएगा 55. Clear? हो गया?
मैम
Clear है?
U में लास्ट थर्ड प्लस 2 होगा ना?
ये क्या था 37? ये क्या था 30? I think someone has changed that value in between, so I didn't check properly. Yes. Yes, it's plus 2. So it's minus 14 आएगा. हाँ बाकी रिमेनिंग सेम है. ठीक है. हो गया अभी करेक्शन? सबको सेम मिला? मिला सेम?
Yes, ma'am.
अभी सबका समेशन फाइंड करना है. Because you have to find here, you have to apply these values in this formula. Oh. This is your formula. So in that we have required summation of ui vi. For finding u bar v bar, obviously ui by n is there. This is nothing but your summation ui by n into summation vi by n. Okay, so obviously you have to find summation u1, summation v also. Yes. So quickly find these values. Okay, okay. अभी एक एक कॉलम का समेशन बताओ क्विकली.
First is minus 51.
Minus 51, then
Second is minus 100.
minus 100,
Then 1169.
1169,
Then 1694.
1694.
Last one removing, ma'am. 2 minutes.
Yes, yes.
One two 70.
What is that? 12?
70.
No, it is not 1270. Minus 14 and minus 7 is there. Just check it again.
One two four two.
Correct. 1242. So you can directly apply this in this formula. This formula. Okay. So we'll write this again. So you're using here assumed mean method. The formula for finding R is equal to covariance of UV divided by sigma U into sigma V. Covariance of UV is nothing but 1 by n into summation 1 by n into summation Ui Vi minus U bar V bar. U bar V bar. Yes. U bar V bar. So what is your n here? This is your what is the total number? How many data we have considered? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. 9 data. So your 9 data are there. Or if I missed anything?
10,
1,
10.
2,
10.
3, 4, 5, 6, 7, 8, 9,
datas.
10. Yes, 10 data are there. I think it was on left side. Yes, so n is equal to 10. N is equal to 10. U bar, we can find it by summation U by n. What is your summation U? Minus 51, right? Is or no? Is or no?
Yes.
And summation V is your minus 100. So minus 100 by 10. So this is minus 5.1 and this is minus 10. So we have all values with us. So n is equal to 10. Summation UIVI is 1242. And U bar is minus 5.1. And V bar is minus 10. What is the value? Quickly find.
$73.2.
Okay, 73.2. Now next I have to find sigma U. What is the formula? Root of 1 by n summation ui square minus summation ui by n whole square or u bar square. Anything you can write over here. So 1 by n means 1 by 10 ui square. What was the value? Summation we have got ui square. 1169, right? Yes or no?
Yes.
And U bar, how much you have got? Minus 5.1. Yes. Quickly find this value.
$9.53.
कोई आया है क्या?
Okay.
कौन?
Yes. Sigma V.
Back shot. Back shot मतलब
Vedant Bhav, sir. Any doubt?
No, ma'am.
Sigma V is equal to 1 by N. Instead of U, we have to write V. So you have to substitute all the values. What is your VI square? One
1007.
1694. 1694, right?
Yes, ma'am.
Yes.
1694. 1694 minus VI square is minus 10 all square. Yes. Quickly find this value.
12.976.
12 point. Sigma V. No,
976.
no. Just check it again.
$8.33.
Yeah. Correct. 8.33. Have you identified the error where you have made the mistake? Yes. Yes or no? So R is equal to covariance of UV divided by sigma U into sigma V. 8.33. Yes. What is this value?
$0.922.
Yes, 0.92. So you can see that the value lies between -1 and +1. It is towards the +1. So I can say that this is highly positively correlated. Okay. So I can write the comment highly positively correlated. That means X and Y are correlated. X and Y are highly positively correlated. X and Y are highly positively correlated. That is the comment. Yes, correlation part is clear.
Yes, ma'am.
Yes, so if you have to do the actual mean, then instead of this U and V, you have to use your X and Y and X bar, Y bar formula. That's all. Clear? So no need to take any deviation. You can do actual. Yes?
Both are same, right?
No, not both are same. Here we have taken the deviation. Here this U is nothing but your deviation. Assumed mean we have used here. Is that clear? Yes or
Okay,
no?
and in that X and Y, we have to remove X minus X, right?
X, here you have X minus, assumed mean is there, Y minus, assumed mean is there. That is your U and B. Is that clear? In actual mean, it is your x and x bar is there, but when you're calculating that, your formula will be 1 by n into summation xi by n. Instead of ui vi, here you have xi yi minus x bar y bar will be there. That's why I have written over here. So it will be easy to remember for these formulas. Clear? 1 by n into xi by. This is your given xi yi, and its actual means. This is your deviation. Clear, but still the formula pattern is same. You can remember easily. Clear?
And
Both are.
ma'am, how do we identify that actual and assumed mean? Means in question.
If in question, if we have not provided anything like that, you have to use assumed mean method or like that. You can use any method. Which one is comfort for you, actual or assumed mean? If you have provided that, you have to consider this number as assumed means that you have to follow the assumed mean method. That's all. Clear. Otherwise, you can do the data. If the data is a bigger one, let it go through the assumed mean method. Otherwise, when you're taking the product and square, you will get a big data.
Excuse me, ma'am.
Ma'am,
Yeah.
means like if we use both the formulas are like almost same, right?
Same pattern is there. Is
Yeah.
that clear? Because if you are using assumed mean, there is a deviation is there. If you are using the actual mean, then after deviation with as actual mean, you are getting this formula. But for remembering, I have considered this. So this is your given x, given y. Take the product. This is your x bar of the given data, y bar of the given data. Take the product. Is that clear? So there is
Okay, so
not,
means
yeah,
in upper formula we are given the values, but in
yeah,
the assumed mean we have
lower,
to calculate by
yeah.
error.
That is first you have to find that deviation. U means the deviation from the assumed mean. V means deviation from the assumed mean of the second data. Clear?
Okay,
And
ma'am.
whatever is
Yeah, yeah.
there, that whatever you are getting the new U and new V, take the mean of that U and V. That is your U bar and V bar. Clear?
Okay, okay, okay.
Okay, that is this.
Excuse me, ma'am.
Yes.
Ma'am, from where we get the recorded lecture link?
I'll share that. Actually, you will get it from the chat of your MS Teams. If you are not getting,
Okay.
then I'll share the link. You just go through that, go to the files of your Teams, and there you can see that. Or in the chat box also you can see that.
Yeah, ma'am.
Yes. Aditya Bangar, just mute yourself. Yes. Any more doubts?
Ma'am,
Ma'am, could you give us any PDFs or links for additional problems so we can practice?
Yes, I can give you, because those who have gone through or have opted for the tutorial exam, obviously, I'll share the assignment sheets to them, so you can also practice those questions.
Okay, ma'am.
Yes.
ma'am,
Yes.
can you just repeat your like how you have considered 35 and 39 as our points of mean?
That I have just taken the lowest and highest value, and in the mid value, I have just taken, that's all. Is that clear? You can take on through in one more method. If this is your x value, then take the sum of all these value, okay? And take its actual mean. Okay? And suppose that this actual mean is some 33.3, then take it 34, or which one is nearer to the value which is here. Take 35. So likewise also you can choose. Take the actual mean and just nearer to that number. That you can consider as an assumed mean. I have just taken the value, one value from that, that's all. Which is lies between the lowest and upper value, in the middle value. Just taken in that way, that's all.
Okay, ma'am.
Yeah. Yes, any more doubt? Yes,
No,
so
ma'am.
you can, yes, so you can expect the questions in the question paper is this type from statistics, coefficient of variation, moment skewness, kurtosis, and the correlation problems. So do practice. And the one more topic is remaining, that is the probability part. So the probability part, you have needed notes, or whether you have needed a video lecture, which one you have required? Because probability distribution you can expect by which one?
Ma'am, video lecture.
Video lecture. So if it is in that case, then I'll make one video lecture part and I'll upload in Moodle. Moodle, all of you are there in the backlog course?
Yes,
If it
ma'am.
is
No,
if
ma'am.
it is okay, if it is not there, I'll
No, ma'am.
share.
No, ma'am.
Just a minute, let me complete. So those who are not there, then I'll means visible that particular in your Moodle course also, so that you can enroll, and I'll provide the key too, because you have to enroll at any cost before doing the remaining activities for IA and all. So obviously you have to enroll in that for SIC course. Okay. So I'll send it through the mail that in what is the name of the course in Moodle, and what is the enrollment key. Okay. So through that you can enroll. Yeah, so probability part, I'll share the video lecture. So three probability distributions will be there, that binomial, Poisson, and normal. So you can expect the questions from that too. Okay, so next SIC lecture will be taken by Cinema. So you will get the link accordingly. Okay.
Can you share like the questions that can be expected in the exam?
So I'll give the question.
Type.
I'll give the question for assignment. So you can do practice. For integral calculus, statistics, and probability questions, I'll provide you. And in this week itself, you can expect the first IA part. Is that clear? So it will be of 1
Based
hour.
on these three topics,
Based
or
on
like
three topics. No, based on 3 topics, it will be of 20 marks. So it will be a 1 hour, 1 hour quiz will be there. So you have to practice these questions. Okay. Yes.
Oh,
So
ma'am, link
the
will be
remaining
shared.
next SIC class.
No, ma'am. Regarding the I.
Regarding IA, that you have to enroll into Moodle. So for Moodle course name, I'll provide you, and the course code I'll provide you, means the key for enrolling. That I'll provide you through mail. Okay.
Yes,
Hello,
ma'am.
ma'am. I have a doubt that those who have already on Moodle, they should not have to enroll now, ma'am.
No, everyone has to enroll. I'll remove all the backlog students because that is already completed now. Okay. So
Okay,
that
ma'am.
data I'll remove now, and this one will be the remedial one. So that will be now fresh.
Okay, ma'am.
Okay. Okay, fine then. Let me download the attendance sheet. Just a second. Okay, thank you all.
Thank you, ma'am.
Thank you.
Thank you, ma'am.